To demonstrate the importance of algorithms, we're going to solve the same problem using two different approaches. The problem we're about to solve is the following. Implement a function that calculates the sum of the first n natural numbers. Alright, let's open up VS Code and create a new file called sumn.py. Now declare a function called sum, which takes a single parameter. This parameter represents the number of natural numbers whose sum we want to calculate. The function returns an integer which gives the sum. The logic of our function is straightforward. It sums up all the numbers starting with 0 up to the value of the input parameter n. First, I initialize a variable called result. Then, I use a for-in loop to calculate the result. So we iterate through the range of numbers starting with 0 up to n. The plus equals operator keeps adding the number I to the result. And finally, we return it. Now we can try out our function. I create a variable, let's call it sum3 equals, and I call the function and pass in the number 3. And let's print the returned value. Alright, now run the demo. The result is 6, which is correct, since 1 plus 2 plus 3 is 6. The sum function relies on a for-in loop to calculate the result. The value of n determines the number of iterations. That means that the time to execute the sum function increases with the input argument n. We can prove this by measuring the execution time. We're going to rely on the time Python module that provides functions to measure elapsed time. Now, what's a module? A module is a file consisting of Python code and can include functions, classes, and variable definitions. To use a Python module, we need to import it. So let's insert a new empty line at line number 1 in the editor and add the following statement to import the time module. Next, insert a new line right after the sum function's definition. We need to call sum with steadily increasing values for n. So let's define a tuple called ranges with the values 10, 1000, 10,000, and 100,000. Then we call sum in a loop using the values from the ranges tuple. I'm going to remove this part and instead let's implement our for-in loop for n in ranges and call sum with the value n. Again, n comes from the ranges tuple. We'll rely on the process time ns function to keep track of the elapsed time. We need to sample the time before and after calling sum to measure the time required to execute the function. I create a variable called start, and let's fetch the time. This function is very accurate. It returns the time in nanoseconds. Next, I create another variable called end, and call process time ns again to initialize it. Finally, all we need is to calculate the elapsed time and print the values. The execution time is represented by the variable exectime, and it's simply the difference between end and start. And let's print the value. I'm using an f string, the value of n, and the execution time is the value of exec time in nanoseconds. Now run the program. And here's the output. Your values may be slightly different, but the trend is clear. The execution time increases linearly with the input. Next, we're going to implement a more efficient solution using a formula that's more than 2000 years old.